Negative 7x plus 3 minus x. I see I have two terms with x on the left-hand side, and on the right-hand side I see a couple of terms with numbers. So I want to combine like terms first before I start to simplify this inequality. Negative 7x and negative x, that's going to give me negative 8x plus 3 on the left-hand side. I have a less than or equal there in the middle. And then I have 5 and negative 12, so I'm going to put that x down, but 5 plus negative 12, that'll be negative 7. And now I'm down to a simplified inequality, more simple anyway. Each side is simplified as much as possible, but now I want to move this x to the left-hand side and combine it with this x term, and then move this 3 to the right-hand side. So that's my process, and I'll start by subtracting x from both sides. Negative 8x and negative x is going to give me negative 9x, and x minus x will go to 0, so it cancels. I have a plus 3 on the left, less than or equal negative 7. And then if I subtract 3 from both sides, I'm doing the opposite of adding the 3. And I will get these to cancel, but I'll have negative 9x on the left, less than or equal negative 7 plus negative 3 will give me negative 10. And now I need to divide both sides by negative 9. Did you hear it? Divide both sides by negative. That means I have to flip, must flip inequality. I must flip it because I put it in, I divided both sides by a negative number. So the negative 9s do reduce, which is great, and I have x, and I have to flip greater than or equal, and negative divided by negative is positive, and 10 divided by 9 is just 10/9. You can write it as a decimal if you want. I think it's 1.11 repeating, but I'd like to leave it as a reduced fraction. And this is my algebraic notation for my solution. If I graph that, and I go from 10/9, it looks like I'm going greater than. Here's the greater than symbol on my graph. Since I have x on my left, I can use that to help me figure out what direction to fill. So I'm filling this direction, and it's greater than or equal, so I do need the square bracket right there at the 10/9. And then I can write my interval notation very quickly. 10/9 with a square bracket all the way to infinity with a parenthesis. Remember, down here it's positive infinity, down here is negative infinity. One more thing to show, and that's set notation. So we'll start our set, and still our variables x such that, and then I can drop in my interval here, so it's going to be x is greater than or equal 10/9. And so I have 4 ways of showing my solution again: algebraic notation, graph, interval notation, and set notation.